we will be talking about how to solve for the derivative of inverse functions. So why is it important to learn about how to solve for the derivative of inverse functions? Basically, our end goal here is to find the rate of change of any point on the inverse function without actually finding the equation. To begin with, we need to understand the definition of a derivative. And basically, the derivative is the slope of a tangent line. And the tangent line is that line that only intersects the graph at one point. So as I mentioned before, we'll be talking about how to solve for the derivative of inverse functions. You're probably all going like,
oh, yeah, how do we even solve that?
First, we need to know the definition of an inverse function. An inverse function is a function where the inputs and outputs are reversed from the original function.
And we need to find the derivative of the inverse of 7. So what we know is y is equal to 7. So let's find the x value by setting the equation equal to 7. Now, solve for x, which gives us x is equal to 2. Now let's find the derivative of the equation. So the derivative of x cubed is 3x squared minus the derivative of 1, which is just 0. So that means our derivative of the function is 3x squared. Now, let's find the derivative of x equals 2. So f prime of 2 is equal to 3 times 2 squared, which is equal to 12. Now in step 4, this is the equation we use to find the derivative of the inverse function. So let's fill it in. Our b is 7, so g prime of 7 is equal to 1 over f prime of 2. Now, we know f prime of 2 is equal to 12, so let's replace that. And that just gives us the derivative of the inverse f inverse of 7, which is 1 over 12.